Right now, somewhere out there, a chunk of rock the size of a city block is tumbling through space, and it looks like a lumpy potato. Meanwhile, right next door, Earth is a near-perfect sphere. Same solar system, same building materials, wildly different shapes. So what's the cutoff? What invisible force grabs a potato-shaped rock and sculpts it into a ball? And here's the part that might surprise you. Not all planets are actually round. Some of them are secretly squished. And our own sun, it's doing something so weird that scientists still can't fully explain it. Let's start with the big question. Why spheres? Why not cubes or cylinders or some other random shape? The answer comes down to one force: gravity. Gravity doesn't care about direction. It pulls equally from all sides, dragging everything toward a common center. Picture a snowball forming in your hands. You press from every direction, and you end up with a ball. Gravity does the same thing, just on a massive scale. When planets were forming billions of years ago, they started as clumps of molten rock and gas, smashing together in a chaotic disk around the young sun. As those clumps grew bigger, their gravitational pull grew stronger. And once an object crosses a certain size threshold, roughly a few hundred miles across, gravity overpowers the rigidity of the rock itself. The material flows, shifts, and settles into the most efficient shape possible, a sphere. That's why every planet in our solar system is round, while most asteroids and comets look like misshapen potatoes. They simply never got big enough for gravity to win the battle. But here's the twist. No planet is a perfect sphere. Not one, Earth included. If you measured the distance from the North Pole to the South Pole, and then measured the distance across the equator, you'd find the equator is about 43 kilometers wider. That's a 0.3% bulge. Barely noticeable, but it's there. Earth is technically an oblate spheroid, a sphere that's been gently squished at the poles and puffed out at the middle. Why? Rotation. Think about one of those spinning amusement park rides where the chairs swing outward the faster you spin. Planets do the same thing. As Earth rotates, material at the equator gets flung outward ever so slightly, fighting against gravity's inward pull. The faster a planet spins, the bigger the bulge. And this is where things get fun. Jupiter completes a full rotation in just about 10 hours. That's over twice as fast as Earth. The result? Jupiter is nearly 7% wider at its equator than pole to pole. You can actually see the flattening in telescope images. Saturn is even more dramatic at almost 10%. Meanwhile, Venus barely rotates at all. It takes 243 Earth days to complete a single spin. The result is almost zero bulge. Venus is about as close to a perfect sphere as planets get. So the rule seems simple. Faster spin equals bigger bulge. Gravity shapes the sphere, rotation distorts it. Case closed, right? Not quite. Our sun rotates at roughly 7,000 kilometers per hour at its equator. Based on its size and spin rate, you'd expect a measurable equatorial bulge. But when NASA's Solar Dynamics Observatory took precise measurements, they found the sun's bulge is only about 12 kilometers across a diameter of 1.4 million kilometers. That's practically nothing. For a ball of hot gas that should flow and deform easily, the sun is strangely, almost suspiciously round. Now compare that to Altair, a star in the constellation Aquila. Altair spins at roughly 286 kilometers per second, over 100 times faster than the sun. Interferometric measurements have confirmed that Altair's equatorial diameter is more than 20% wider than its polar diameter. That star is visibly egg-shaped. So Altair behaves exactly as physics predicts. The sun doesn't. And right now, scientists are still working out why. Some researchers suspect the sun's powerful magnetic field or the intense outward pressure from nuclear fusion deep in its core might be counteracting the rotational forces. But no theory has been confirmed yet. It's one of those quietly fascinating unsolved puzzles sitting right in our own cosmic backyard. So the next time you look up and see a planet gleaming in the night sky, remember, it's round because gravity demanded it, slightly squished because it can't stop spinning, and part of a universe where even our nearest star is keeping secrets. If you learned something new today, hit that subscribe button and drop a comment telling me which planet's shape surprised you the most.